Why is the universe so perfectly set up for life? Change the strength of gravity by a hair and stars never form. Tweak the nuclear force by a couple percent and carbon, the element that makes up you and me, never exists. The universe appears almost suspiciously well suited for our existence. So what's going on? Is this just a cosmic coincidence? Evidence of a designer? Or is something else happening, something about the very nature of observation itself? This is the puzzle that leads to one of the most fascinating and controversial ideas in all of science, the Anthropic Principle. Welcome to Grossdenken, everyone. Today, we are going to explain exactly what the Anthropic Principle is, the different forms it takes, and why physicists are still arguing about whether it is profound or just a fancy way of stating the obvious. Please support this channel by just subscribing. That would mean a great help. The term Anthropic Principle was coined in 1973 by physicist Brandon Carter at a symposium commemorating the 500th birthday of Nicholas Copernicus. And here is the irony. Copernicus famously demoted humanity from the center of the universe. Carter, on Copernicus's birthday, said something that sounded like the opposite. Carter's principle states, "What we can expect to observe must be restricted by the conditions necessary for our presence as observers." That sounds complicated, but the basic idea is simple. We exist. Therefore, the universe we observe must have properties that allow us to exist. If the universe were different, if gravity were stronger or carbon didn't form, we wouldn't be here to ask the question. Stephen Hawking put it more memorably. We see the universe the way it is because if it were different, we would not be here to see it. This sounds almost like common sense, but as we will see, the devil is in the details. Carter actually proposed two versions of the principle, with very different implications. Most physicists accept one, most reject the other. First, the weak anthropic principle. This says that our existence as observers imposes a selection effect on what we can observe about our location in the universe. Here is an analogy. If you win the lottery, you shouldn't be surprised. Someone had to win, you just happened to be the one who did. Similarly, we shouldn't be surprised that we live on a planet at the right distance from the right kind of star. If we lived somewhere else, we wouldn't be here to notice it. The weak anthropic principle is widely accepted. It is not a theory of physics. It is a methodological rule. When you are doing science, remember that your observations are filtered through the fact that you exist. Then there is the strong anthropic principle. This makes a much bolder claim. The universe must have properties that allow life to develop at some point in its history. In other words, the laws of physics were somehow forced to produce us. This version is far more speculative. Many scientists consider it closer to philosophy or even theology than to testable science. So why did Carter propose this principle? Because of a genuine puzzle in physics, fine-tuning. Take the famous example of carbon. In the 1950s, astronomer Fred Hoyle predicted that there must be a specific, previously unknown energy state in the carbon-12 nucleus. Why? Because without it, stars would not produce carbon. And without carbon, we would not exist. Hoyle used this logic to predict the resonance. It was later discovered exactly where he said it would be. This pattern appears across physics. If the strong nuclear force were just 2% stronger, hydrogen would have fused too quickly after the Big Bang, leaving no hydrogen for water or long-term stars. If it were 2% weaker, deuterium, essential for fusion, would not exist. If the cosmological constant, the energy of empty space, were even slightly larger, galaxies would never have formed. The list goes on. The constants of nature appear to fall within an extraordinarily narrow range that allows life. Fine-tuning needs an explanation. The Anthropic Principle offers one, but it only works if we add something else. If our universe is the only universe, then the fine-tuning seems miraculous. But if there are countless universes, a multiverse, each with different physical constants, then it is no surprise that at least one has the right conditions for life. We simply happen to live in that one. The weak Anthropic Principle, combined with a multiverse, gives a natural explanation for fine-tuning without invoking design. Other explanations exist, maybe it is pure coincidence, we just got incredibly lucky. Maybe the universe was designed, but that is a theological claim, not a scientific one. Or maybe a future theory of everything will show that the constants are not free parameters at all. They are mathematically forced to be exactly what they are. Here is the honest truth. The Anthropic Principle is controversial. Critics say it is unfalsifiable, you cannot test it. And if you cannot test it, is it really science? The physicist Heinz Pagels called it unscientific. Another called it virtually trivial. The weak version is widely used as a cautionary tool. The strong version is largely rejected by the scientific mainstream. That said, with the rise of string theory and the idea of a vast landscape of possible universes, anthropic reasoning has become more common in serious physics, though it remains deeply debated. So what is the Anthropic Principle? At its core, it is a reminder. We can only observe a universe that allows observers to exist. That sounds obvious. But whether that obvious fact explains the strange fine-tuning of our cosmos, or just restates the mystery, is one of the deepest questions at the edge of physics and philosophy. Thanks for watching. If you want more deep dives into the biggest questions in science, what we know, what we don't, and how we figure it out, hit subscribe.